Okay, let's see if we can get through this. I opened the calculator. So the first thing it asked me is to find P of 24. And so what that means is simply plug in 7.358, 1.013 raised to the 24th power. And I'm going to do it over here, 7.358, 1.013 raised to the 24th power. And that gives me 10.123456. I think it's in 5 decimal places. And this is the population. So this is the population in somewhere, it tells you billions in 2039, because 2015 would be P of 0, so in 24 years, this would be in 2039. Next, it asks to find the derivative. Okay, so the derivative, this is, I even give you the hint, is the a to the x. Let me kind of get this where I can still see my function. So the derivative then, oops, I thought I clicked that thing. The derivative, or the change in population over change in time, would be the 7.358 would be out front. This is the a to the x. The a to the x is the a to the x. Oops, so that change stays the same. And then times ln, so the natural log of 1.013. All right, so that is the derivative. Now this here wants me to find P prime of 24. And so all I'm going to do is take this equation right here, and where I see t, I'm going to plug in 24. So if you look over here, that's kind of this. I just have to do times ln of 1.013. And so I get equals 0.129576. I don't know if that was 1, 2, 3, 4, 5. Again, I'm going too many decimal places. And remember that this is a rate. So this is in billions of people per year. And again, this is where, you know, the change in the population over the change of time, dp dt, helps with my actual units. All right, so now here I want to find the tangent line, and then I'm going to graph all this. So what you want to do is the first thing, graph your function. I'm not sure I have it memorized, 7.358 and then 1.013. And if you notice, I am using x's, which is fine. Let me make sure that's right. 7.358, 1.013. Okay. And so now I want to do the tangent line at that point where x is 24. And I'll show you something that's cool in Desmos, is you can actually find f of 24. Okay, so that was this value right here, so it'll find it for you. You can also find f prime of 24, so that was this value that you see right there. So it will do the calculations for you, but what's really cool is you can do the tangent line with this same formatting, meaning y minus y1, which is the function evaluated at 24, equals the slope, which is the derivative at 24, and then x minus x1, which is 24. Let me change, didn't mean to do that. Let me change the color here. And so what you should be seeing is this line only touches at that one point. Well, what is that one point? 24 comma f of 24. So if you plug in 24 into y, then you see it's only going through that one point. And so, and you can answer these. And so now what we're looking at is we're saying, well, how could we do P of 25? And so we want to take what we knew from P of 24. So let's kind of go back here and grab some stuff. So here is, if I can get it to grab, here is P of 24. There we go. Oh, that's ugly. And then my P prime of 24, which is right here. So P prime of 24. Let me get my math again. There's P prime of 24. I don't really care about all that because I did this already with my calculations. I just need the numbers. And so all you're doing here is you're just looking exactly what it says to do. So it says take P of 25 is what you want. What you know is P of 24, so 198, plus the rate that you know, 58, and then times the gap. The gap is what you want, the 25 to 24. So that's what you would be plugging into a calculator. Then on this slide, it's saying, well, why would you even do that, make that prediction? Why wouldn't you just go back and take your original function and plug in 25 and compare this to this? This is an approximation based on the actual rate. This is an exact value. And sometimes we like to update based on that rate being updated. All right, so the same thing's going on here. So P of 45 is what I'm trying to find. I need P of 25 plus P prime of 25, and then the gap from 45 to 25. So probably what I would do is I would go back to this slide. So I have my graph and get rid of all this junk. I want to keep that one. So I want to know what F of 25 is, and I want to know what F prime of 25 is. Okay, so those are the numbers that I'm going to need, and I'm certainly not going to remember them. I wonder if I can copy this. We will see. So F of 25, F of 25, or P of 25 in this case, equals that value. And then, F prime of 25, this once again is your slope. Which would be P prime of 25, which is the slope, and it apparently didn't copy, so I got to go all the way back to those slides. This value, would you copy? 131259, 132. Just in case it didn't copy. There we go. All right, so you have everything you need here. So now you just simply plug everything in. So P of 45 would equal P of 25, this value here with however many decimals, plus your rate, okay, however many decimals, and then of course 45 minus 25. So that's what you're doing. What I would do here is I would go back and do the same thing we did on the other one. So I'm actually looking at, now that I'm trying to predict P of 45, and I'm doing this with Y minus my F of 25, my F prime of 25, and then my 45 minus 45 minus 25, my X minus 25. So that would be this value. If I want to look at the actual point, 45 comma, I keep typing in the wrong number, then I can plug my actual point and I can see that it is going through that point.